next question is question 2a. Explain the operation of a simple shunt voltage regulator. Okay. So voltage regulator, Zener diode voltage regulator. So you know that this is your circuit diagram of your Zener diode voltage regulator, where you will be having the input as your unregulated DC signal, which will be given to your variable resistor RS. This is also called as your current limiter. Okay. It limits the current, flow of current. And you have your Zener diode voltage. You know that Zener diode operates in the reverse bias condition. Okay, so this is negative, positive, and you have an RL connected. So what will be your output? The unregulated DC signal. So this is your sample signal, which consists of the ripples, will be converted into your DC. So DC signal. Okay, smooth DC signal. So what will be your value in this case? For example, in this the specification is the Zener diode voltage has a voltage of 5 volt. Okay, so your output will be constantly maintaining in 5 volt. So this is your operation of your Zener voltage regulator. So here you have RS limits the Zener current to a safe value. A voltage regulator is an electronic circuit that provides a stable DC voltage independent of the load current, temperature, and AC line voltage variations. A voltage across the Zener will remain steady at its breakdown voltage Vz for all values of Zener current, right? So this is your breakdown voltage as long as the current remains in the breakdown region. Hence a regulated DC output V0 is equal to, so this V0 will be always maintaining in your Vz value, is obtained across RL whenever the input voltage remains within your maximum and the minimum voltage. So since your input resistor is controlling, let us find out the value for RS max and RS min. Okay. So in order to find out the RS max, what you will be getting, you have to find out what is your V Thevenin's voltage or your voltage Vz. So what will be your voltage Vz? Vz will be by applying your voltage division rule. What will be your Vz? Vz will be equal to the resistor across which you have to find out, right, the voltage. So RL into total number of resistance, RS plus RL, into your input voltage. Input voltage is taken as your Vin. Okay, so this is as per your voltage division rule. Okay, so Vz is equal to RL divided by RS plus RL into Vin. So cross multiply it. Vz into RS plus RL is equal to RL into Vin. Now you do the simplification. Okay, cross multiply inside, you will be getting this. Now you have to separate. What is your aim? You have to find out RS max. So RS max is equal to RL into Vin minus Vz divided by Vz. So I can write that RS max is equal to Vz get cancelled and you will get 1, right? RL into Vin divided by Vz minus 1. So this will be your RS maximum value. So if you want to find out your RS minimum value, what you will do? You know that R is equal to V by I. So what is your V? V is equal to Vin minus your Vz, right? So you already know that. So when RS is minimum, your current will be maximum. That's why you have written as Iz max. But you know that the maximum power dissipated is equal to Zener diode power Pz max is equal to Iz max into your Vz, right? So can you substitute the value for Iz in this equation from Pz max? So what will be your Iz max? Pz max divided by Vz. So I have substituted this here. Okay. So after simplification, what you will be getting? Vin minus Vz. Bring this Vz to the top. Okay. Divided by Pz max. So RS minimum will be equal to Vin into Vz minus Vz square divided by Pz max. So this much you can write it for this question. Okay. The detailed explanation is given in the playlist. Okay.